Okay, welcome to the next video in the systems programming sequence. In this video, we'll talk about conditionals and loops. So as we have been doing in previous videos, we're going to see a Python example. Here's an example of executing a if-then, or if-then-else, I guess you could call it. Anyway, so the way this works is you get a number. Here we're doing it by getting input from the user. Could come in other ways, but in this particular example, that's how we're going to do it. And then you get another input from the user, and we say that if the num1 value is greater than num2, then the following code executes, which it says that num1 is biggest. Okay, sure. And then assigns num2 equal to num1. Okay, so that's what happens if num1 is bigger. If that is not the case, if num1 is not bigger, then we say that num2 is the biggest, and then assign num1 equals num2. So it looks like, at the end of this process, num1 and num2 will both store the biggest of the two values that were entered. Okay, that's our main function, and as always, after defining the main function, we call the main function. Let's see the same thing implemented in C. So to get input-output, we import the standard IO. We define our int main function. We declare a couple ints. We grab these values from the user, right? Similar to the Python thing. We're going to get these inputs from the user. The syntax here is only slightly different, right? We don't use colons, right? I am moving somewhat fast, assuming that the viewer is at least a little familiar with Python, or at least can kind of pick it up quickly. But this is how Python writes things, right? If something that evaluates to a boolean, colon, and then indentation, so long as you're living inside of the if condition. If you want an else clause, then you can put an else clause unindented with a colon, and then everything indented after that is inside the else clause. Okay, well, so you can see that as so often happens with the difference between Python and C, what Python does with indentation, C does with curly braces. So to be inside the if, body, we could say, is to be inside the, the first set of curly braces. And then to get an else clause, after the closed curly brace, you write else, another open curly brace, and then you can write the else clause. I think that's fairly straightforward, so we'll just move right along. You can, in principle, this is true both in Python and in C, you can simply write an if condition. Or if you want a so-called two-way branch, then you can write an if-else. This is also true in Python, although I believe in Python, rather than writing else if, Python abbreviates that to elif. But in any case, you have an if, you have an else if, right, which is basically like an else statement joined with an if, like a further if statement. You can do this as many times as you want. I'm going to assume that all of this is relatively familiar to the viewer from some kind of programming background. Now, everything that we have said, though, has been somewhat disguising, or at least ignoring, a little bit of a subtlety about what makes a way that C is different from Python. Truly has Boolean values. It has a true value. It has a false value. That's not the case with C. So rather, here, let's look at an example, right? In C, this greater than operation, if you're coming from a Python or a Java or a lot of other backgrounds where you're used to that kind of a thing, returning, right, evaluating to a true dedicated Boolean value, that's not what happens in C. This returns an integer. And in particular, if the statement is true, it will return a non-zero integer. It doesn't matter which one. almost certainly it returns 1, but all that really matters is that this returns a non-zero integer. And the way that C works is that, in an if condition, if that condition is non-zero, it is treated as true, and we therefore enter the if block, and we do not enter the else block. So if this, right, if num1 really is strictly bigger than num2, that will evaluate to a non-zero value. And because it evaluates to a non-zero value, C will enter the if block. If num1 is not strictly bigger than num2, this will evaluate to 0. And because it evaluates to 0, then C will enter the else block. So everything is done with integers. There are no Boolean values in C. We talked about the greater than operator. Well, the same principle applies to equality, right? Testing for equality, testing for inequality, and all the other operators that you may be used to thinking of as returning a Boolean. In C, technically, actually, they just return an integer value, and then C if statements just know that if you see a 0, it's treated as false, and if you see a non-zero, it is treated as true. You can test this out on your own. You can write your own if block and just directly put, a 0 or a 1 or a 2 or a whatever, and you can check the behavior directly by writing yourself a simple little program. So, okay. There are logical operators, right? So there is negation. It's written with the bang symbol, right? So if you say bang, let's just say 0 less than 1, right? So we're used to thinking of this as returning true, and the bang operator applied to true returns false. So indeed, this basically evaluates to false as we are used to it doing, but actually, as far as C is concerned, that's really just the number 0. So anyway, there's a negation operator. You can do something that you would think returns a Boolean, even if you know that it actually returns an integer. It still negates that value, let's say, and behaves in the way that you would expect it to behave. Namely, that true values, when negated, become false, and false values, when negated, become true. Okay. We have a logical conjunction, right? This is like saying and, right? This value and that value behaves just as you would expect, right? That effectively 0 less than 1 and let's say 1 less than 2. This would evaluate to true, so to speak, except actually probably 1, I'm going to guess, right? I don't actually know I haven't looked up what non-zero value it evaluates to, but one would think that you would just pick the simplest non-zero value, so why not 1? That's my guess. But in any case, right, this behaves like the value true, even if technically, as far as C is concerned, it's actually just a number, an integer. Okay, anyway, so there's logical OR written that way, and so on. C does all of its logical operations by short-circuiting. So what that means is that, for instance, let's say that we're talking about and. Well, if this value comes out false, there is just no way for the and statement, so to speak, to come out true, right? Because as soon as one value is false, the conjunction is going to come out false, and therefore C does not even try to evaluate the right-hand side. It simply immediately returns false in that case. If it's true, then it has to continue, right? So if the first condition is true, then it will continue on and check the second condition. And if both of them come out true, then it returns true. Otherwise, it returns false. But the point is just that if it can decide this early without ever computing the second thing, it will. So the same idea applies to disjunction, except that with disjunction, it's when the first disjunct is true that it can do a short circuiting, right? Because the disjunction will come out true if the first one comes out true. It's guaranteed. You don't need to check the second one, so it won't. One thing that's kind of nice about this feature of short circuiting, and it's sometimes done this way somewhat intentionally, is what if the second block of code for some reason would cause an error or an exception and like crash your program, basically. Kind of what you can do is you can make the first condition, sort of come out whichever way you want, right? Depending on whether you're talking about conjunction or disjunction. But basically you can sometimes you can design it so that if the first condition is true, then great, it's short-circuited. That error will never occur because of the short-circuiting. But if it comes out false, then basically coming out false is almost kind of exactly the condition that would be needed for the second part to not throw an error. I'm talking very abstractly. Maybe this is not a point worth making right now. Maybe if it ever comes up in practice, we can kind of see it in action. But in any case, all you really need to know is that these logical operators do short circuiting, and sometimes they can have nice properties in how you write your code. Okay. Okay, let's move on to talking about loops. So I guess we're going to start by talking about while loops. And so in Python, number, right? We got one number, I guess. And we, take its absolute value, right? So if the number is negative, then we set it equal to its negative, which basically just takes the absolute value. Okay, then we declare this value, val1. I don't know where this is going. I haven't thought about this in advance of making the video, but okay, so we're declaring a val1, and then what are we doing? While val is less than num, then what do? We print the value, and then we double the value. Okay, so I guess we're basically just we're starting from 1 and doubling it as many times as is needed, basically, to get a value equal to or bigger than num. And along the way, we're printing all the values. Maybe not the most interesting program, but I see what's going on there. So anyway, but this is how a while loop works, right? Is you declare while, you set up some boolean condition. In Python, there truly are booleans, so that's not even like a euphemism or whatever. That's an actual boolean value. So long as that comes out true, we enter the while loop, do whatever it says, and then start all over again. And we keep doing this over and over again indefinitely until, hopefully, eventually, this condition becomes false. That should happen in this case, right? Because no matter what num is, it is some finite number, right? And we're gonna and it's positive. And so if we double val enough times, right? That's what's going on here. We keep multiplying val by 2 over and over again. And if we keep doing that, eventually val becomes larger than num, and this while loop will terminate. And so that's the while loop. And then, okay, as always, we call the main function. And that's this Python program. Okay, let's see how to do the same thing in C. So we get input output, we declare in our int main function a couple of integer values, we get a value from the user, that's num, we take the absolute value, right, using an if block. Okay, so that's nice to see that in practice. Declare the value val1, And here's our while loop. So, notice how it's different. As always, with C as contrasted with Python, C really requires those parentheses, by the way. Probably should have said that in the context of the if structure. But yeah, so in C, you have to always have these parens. And then you should always have these curly braces delimiting the inside of the while loop. We print the current value of val and then double it, just like the logic of the Python example. And we do that until the while condition breaks, and when it does, we finish off, right? Terminate the program, indicating success. And so the C program does the same as what the Python program does. Here is a generalization of how while loops are generally written, with a boolean expression inside of the parentheses. Of course, right, that's not really a boolean expression. It's actually, right, some expression that evaluates to an int, but we know that, C will always read that int as if it was code for a boolean. Okay, whatever, I beat that dead horse. Then inside of the curly braces, you write the body of the while loop. Okay. You also have this do while structure. I never use those. You're free to read about them, but I find that kind of a waste of time. I'm sure it's sometimes nice, but whatever. Okay, so next we look at for loops. In Python, okay, so as always, def main, right? That's always the start of how we're structuring our Python programs. Get a number from the user, take its absolute value, do a for loop over range num. Now, what is range num? Let's say if num was 5, let's say, then range num is effectively, this is not exactly true, but it's effectively as if it were 0, 1, 2, 3, 4, right? 5 values starting from 0, going up to 5, but not including 5. That's what range num kind of does. It gets you a list, right? Basically, you input a number and it gives you out a list. And so the way that for loops work in Python is you always for loop with some kind of a variable. Here the variable is I, taking values in the list, right? So initially, right, on the first run of the for loop, I absorbs the value 0, and then the body of the loop does whatever it does using the value 0 for I. So, this might as well be 0, right? It's going to print out 0 in my example. Okay, when that's done, it goes to the next element in the list, and that is now absorbed by the variable I, and it does whatever it does with the new value of I. In this case, that would be the value 1, and then this is saying that it would print out the number 1. And then it proceeds so on and so on through the list, right? I, on every pass through the for loop, always absorbs the next value and does whatever the body of the for loop says to do with that value, and then increments to the next thing in the list and does it all over again, and so on until the end of the list. That's how for loops work in Python. And of course, at the end, call the main function. Okay. In C, okay, we're going to get input output. We're going to do our int main function, declare some ints, get a number from the user, take its absolute value. And now here's how you do for loops in C. This, if you have familiarity with Java, this is basically exactly how it goes in Java. You do an initialization of some sort. I guess since I was already declared as an int up above, then you don't need to do it here, although you can put your int declaration. Oh, actually, I think that's true in Java, but that's actually not true in C. I don't know. Anyway, if you want to be on the safe side, declare your variable outside and then initialize it here in the for loop. That's bound to work. And then semicolon. And then some kind of a boolean condition, whatever this boolean condition is, determines when the for loop will break. And then this is an increment command, right? So this happens at the end of every pass through the for loop's body. So effectively, right, if num were equal to 5 here, then what this would do is initially set I equal to 0. It would print 0 and then perform this increment, which means that on the next pass, I would be equal to 1. And then it would do the body of the for loop all over again, which is to say, now it prints 1. And again, it does the increment and computes, evaluates the rest of the body. Along the way, every single time, I should have probably said this earlier, checking to see whether the condition is still satisfied. So as long as I is equal to 0, the condition is satisfied, and we do it, right, we execute the body of the for loop. When I is equal to 0, it's less than num, because again, recall, we're imagining that num is equal to 5, 1 is less than 5, so it keeps going, and we get to I is 2, I is 3, I is 4, I is... Now, when I is 4, it prints 4, it increments, so I now takes the value 5, but because now 5 is not less than 5, this evaluates to false, and that causes the for loop to terminate, and then we come down to return 0, indicating success. So that's how a for loop works in C. Here is a more abstract description of how to write for loops, right? There's an initialization, a Boolean expression, and a step command or whatever, and then the body of the for loop. I've already walked through sort of the logic of how a for loop runs, so you can read the book if you want to see their description of it, but there we have it. Is anything worth discussing here? Executing the for loop evaluation rules on the preceding. Oh yeah, so here it's basically just going to take this example and do an explicit walkthrough, somewhat like what I did up above, but we don't need to do another. Okay, cool. Okay, so here's a complex, what they're calling a complex for loop, which I guess is complex in part because there's not just one initialization here. You actually have the power to do multiple initializations, which I didn't know about until I read this book, but I don't think I would ever use that anyway. But in any case, you can do multiple initializations in the initialization part. You can also do multiple steps in the step part, all at the same time, right? So basically what this is going to do is I and j are both initially equal to 0. We will exit the for loop whenever I becomes less than 10. And along the way, at the end of every pass through the for loop, we're going to bump I up by 1, and we're going to bump j up by 10. And then we do this. And I guess that's, that's kind of neat that you can do that in C, but I don't see that as being terribly important for the things that we're going to do, so whatever. But, good to know. Okay. What do we have here? So, oh, right, it's going to show us that in C, for loops and while loops are equivalent in power. That is to say, whatever one can do with a for loop, it can also be done with a while loop. And that's somewhat clear with a while loop, right? How could a while loop reproduce what is done with a for loop? Well, you could basically just start off some, int I equals 0, and then say while let's say I is less than 10, and then you do whatever you do, and you try to just make sure that, along the way, at some point, I gets incremented on every step of the while loop. And this basically acts like a for loop, going, for I from 0 up to 10. So it's somewhat easy to see how you could get the behavior of a for loop by using a while loop. What about the other way around, right? What about getting the behavior of a while loop using a for loop? Well, that's not always possible. They point out here that in Python, it's not possible. But in C, it is possible. And that's because in, C, you get to specify a breaking condition. So that basically just makes it exactly like a while loop, right? That, okay, you do have to have an initialization thing. Let's just say I equal to 0. I less than 10. This is your breaking condition. Well, whatever you put for the breaking condition, you could just as well, could be what you would have put as the breaking condition for the while loop. And whatever you do to increment your variable here, in a for loop, you just put it here. But anyway, so without, sort of parsing this too carefully, I think it just makes a certain, it's believable that you could use a while loop to reproduce a for loop, and because in C you get to specify the breaking condition for your for loops, then actually you can use for loops to do the same thing as a while loop by specifying the breaking condition right there. So anyway, I think that's enough of a description of what's going on there. That's that. Okay.